So this is where we stopped Thursday. So we got to this, not this problem, but this problem Thursday. And this is where we stopped. We solved this one here using some of the properties of logarithms. So we're going to look at this one here. Now, one of the big things with these here is that if I'm trying to solve it, it's going to be nice to get rid of the logarithm. And then I know that if, since I have a logarithm, if I put it to a base of 6, 6 to the log base 6 will simplify out. It'll make it easier to work with. But I cannot do that if I have two logs. And here I've got two different logarithms. But we can rewrite them as a single log. And it's using our property of multiplication. Because if we have two logarithms with the same base being added together, I can rewrite it as multiplication of what's inside. So here we're going to have log base 6 of 6x times x minus 1 is equal to 2. So if we have two logs with the same base being added together, we can rewrite it as a single logarithm with what's inside the log being multiplied together. So we end up getting this here from the properties of multiplication with our logarithms. Now at this point here, we're going to use another property. And we're going to put both of these to the base of 6. And the reason that we do this is because 6 to the log base 6, this part here of this equation will simplify out completely. Because as we covered this before, b to the log base b of x is going to simplify to x. And that's why that we do this here, because it works out nicely. And when that simplifies, what we're left with is 6x times x minus 1 is equal to 6 squared. So using that property there, we're able to get rid of all of the logarithms from our equation and deal with something we are used to solving. So any questions on any of this here so far? Well, now we can simplify this a little bit. We can use the distributive property. Well, 6x times x is going to be 6x squared. 6x times negative 1 will be negative 6x. And 6 squared is 36. So we get this here. Any questions on any of this here so far? Now, because this is a quadratic, we do have an x squared term. We need to get everything on the same side of the equal sign. And to do that, we can do what? Well, we can subtract 36 from both sides of the equation. And what that'll give us is 6x squared minus 6x minus 36 is equal to 0, because these here will cancel out. Any questions on this here so far? Is there a greatest common factor between all three terms, or all four terms? 6. 6 will go into 6, 6 will go into 6, and 6 will go into 36. And 6 divides into 0 evenly. So since there's a common number between all four terms, we can divide everything by 6. Well, 6x squared divided by 6 is just going to be x squared. 6x divided by 6 would just be x. 36 divided by 6 is 6. And 0 divided by 6 would be 0. So we get this here. So what we're left with is x squared minus x minus 6 is equal to 0. So what can we do from here? We can factor it. We we can factor it. So we'll have our two sets of parentheses. Since the third term is negative, our signs are going to be opposite. One's going to be positive and one's going to be negative. Bless you. The factors of x squared are going to be x and x, because those are the only factors of x squared. And our factors of 6 that we want to use would be positive 2 and negative 3, yes. Any questions on this here so far? Now, because we do have two things multiplied together to equal 0, means one of these must be equal to 0. So we can set both of them equal to 0 and solve for the value of x. So for this one here, we would subtract 2 from both sides of the equation, which would tell us x is equal to negative 2. And for our other equation, we would add 3 to both sides of the equation. These would cancel and tell us that x is equal to 3. Any questions on any of this here so far? Now we do need to check this here. We need to make sure that when we plug these values in, we do not have a negative inside the logarithm. So negative 2 and 3. So if we come back up to the top and we plug negative 2 in to the original problem, log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1. We cannot have a negative in any of these logs. Well, 6 times negative 2 would be negative 12. Well, negative 2 minus 1 is negative 3. So x equals negative 2 does not work because in both logarithms we do have a negative. We cannot have negatives inside of the logarithm. So x equals negative 2 does not work. Now if we plug in 3, base 6 of 6 times 3 plus log base 6 of 3 minus 1 is equal to 2. Well, 6 times 3 is 18. 3 minus 1 is 2. Well, inside of both of these logs here, we do have positive numbers, and it would go on to solve. We're able to solve this here and see that, yes, this is a true statement. So x equals 3. This here is our solution for this equation. Any questions on any of these here? Any question on anything we've done so far? We good with these here? Yes? We'll go on and look at this one here. We'll look at one more of these, and then we'll move on to the next type that we're going to look at. Because the only other thing we're going to look at today is inequalities. All right, let's change this up a little bit. Let's do we're going to do LNs instead of logs. It'll change it a little bit, and it'll be helpful for your assignment if we look at the natural logs. Now, our overall properties of natural logs and logarithms doesn't change because a natural log is a logarithm, but it has a base of e. It's understood to be e. Now, according to our multiplication property of logarithms, if two logs with the same base are being added together, then we can rewrite it as one log with what's inside being multiplied. Now, what can we do next? We're going to put both of them we're going to give both of them a base of e, because e to the ln here simplifies out because the base and what we put it to match up. They're the same. Now what that leaves us with is 5x times x minus 1 is equal to e squared. Any questions on any of this here so far? We can go on and simplify, because we can use our distributive property. 5x times x would be 5x squared. Minus 5x times negative 1 would be negative 5x is equal to, is e squared going to be a whole number? Is e to the second power going to be a whole number? What kind of number is e? It's 2.7 going on and on and on. Is it? And it just keeps going. It's a non-repeating, non-terminating decimal because e is irrational. So will e squared give us a whole number? Well, no. But we do have a quadratic, yes? So we can move everything to the same side of the equal sign. So I can subtract, try that again, subtract e squared from both sides. And if I do that, what we'll get is 5x squared minus 5x minus e squared is equal to 0. Now at this point here, and all the ones we've done up to this point, we've been able to have a greatest common factor and we can factor it. 2 sets of parentheses and solve. Well, e squared, as we've already seen, this is a non-repeating, non-terminating decimal. There's going to be no good way to find two numbers that multiply together to give me e squared besides e and e. And if that were the case, the middle term would have to have e. So this here does not factor. But we can still find the values of x. Because we can still use the quadratic formula. E squared, as we already saw, is a number. It does have a value. And we can use this formula to plug it in. So the first thing we have is negative b. Well, the value of b is negative 5. Well, a negative and a negative make a positive. So we have 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative e squared. Not 1. I'm so used to the value of a being 1, but it's actually 5. I can write 5 times negative e squared, all over 2 times 5. So we should have 5, because negative negative 5 would just give us 5, plus or minus the square root of negative 5 squared minus 4 times 5 times negative e squared, all over 2 times 5. Any questions on any of this here? Okay. I'm going to split them up at this point here. Because if I were doing this and trying to solve this here, and I already know that the homework and what these are going to come up, and when these come up, they're going to ask you to round your answers to the nearest hundredth, 2 decimal places. So since I know that, or we already know that e is an irrational number, and I'm taking the square root of an irrational number, this is not going to come out nicely at all. So what we're going to do and end up doing is just typing these in. I split it up into our 2 cases, our plus and minus. I made it into one case where it's positive, one case where it's negative. And at this point here, we can just type this all in the calculator. We don't have to simplify any of it here. We can do 5 plus the square root of negative 5 squared minus 4 times 5 times negative e squared all over 10. And if we typed all this in, we would get that x is equal to 1.8144 going on. And if we went to the nearest hundredth, it'd be 1.81 would be the answer if we typed all this in. Now luckily, since these two are the exact same except for the fact that this is minus in front of the square root instead of plus, you can recall it and just change it from addition to subtraction, which will tell us that x is equal to negative 0.8144. But since we're going to 2 decimal places, it'll best be negative 0.81. So we do get some ugly decimals on these here. Any questions on these so far? Is there one of these two that we know that will not work? This one here, because it is negative. Because if I look back up at the starting equation, if I type it into this one here, 5 times x, a positive number times a negative would give us a negative number inside one of the logs. It does not work. But this one here will work for both of these here. And if we plug it in, it'll work. It'll get close to it. It won't give us exactly 2 if we typed 1.81 into the calculator, because the actual answer isn't exactly 1.81. It's 1.8144 going on and on and on. It's an on-repeating, non-terminating decimal. But that's all we'd have to do for these here. So some of them we might have to use the quadratic formula to be able to find our answer. Are there any questions on these here? All right. Let's move on to inequalities. 3 to the x is less than 20. And we covered these on Thursday of last week. We had problems similar to this here, but instead of inequalities, we had equations. So instead of greater than or less than, we had equals to. And what we did to solve these here is we use, for this one here, it'd be log base 3, and we would apply it to both sides. Because whenever the base and what's inside the logarithm are the same, log base 3 of 3, this simplifies to 1. And really the exponent gets moved out front, and we really just have x by itself because this here simplifies away. And on the other side, we're left with log base 3 of 20. And at this point here, we just need to evaluate log base 3 of 20 And all we've got to do is plug this into the calculator. And log base 3 of 20 is approximately 2.726833028. Or if we wanted to go to 3 decimal places, we can say 2.73. Or if we're going 3 decimal places, it's 2.77. We're just rounding. Any questions on any of this here? Any questions over anything we've done so far? Now with exponential inequalities, the values of our answers really don't matter. Because we could have 0, we could have positive, we could have negative values for x in an exponent. Because the numbers, the values that we can plug into here, it doesn't matter if they're positive, negative, 0, rational, irrational. We can plug any of them in as long as they're real. We don't deal too much with complex or imaginary exponents in Algebra 2. So for this one here, how would I get the variable out of the exponent? What can I do to simplify e? We can take the natural log of both sides. Because the natural log of e is 1, and really that exponent goes out front and just this whole side simplifies to x, which is less than the natural log of 2. So at this point here, I just need to find the natural log of 2. What did we get? 0.6931. And that's it. That's all we have to do for these here. Any questions on any of these here thus far? We feel good with these here? So what would we use for this here? Log base 10, or we can just write it as log. Because our logarithm, if we don't have a base written, it is understood to be 10. And the reason we use log base 10 or just log is because log base 10 of 10 or log of 10 is 1. It simplifies out, leaving us with just 2x minus 6 is greater than log of 3. Any questions on this so far? Now we still need to solve for the value of x. So what can we do first? We can add 6 to both sides, yes? And if we add 6 to both sides, well, negative 6 plus 6 will cancel, giving us that 2x is greater than log of 3 plus 6. And last but not least, we can by 2, which will tell us that x is greater than log of 3 plus 6 divided by 2. We had to get x by itself. And at this point here, we can plug this into the calculator and it would give us our answer. And if we type this in, what we'll get is 3.239. And this is just rounded to 3 decimal places because the actual answer will be 3.238560627. It's a non-repeating, non-terminating decimal. So it would continue out for quite a ways. Any questions over any of this here so far? So no questions over this here. Let's look at our logarithms. Now with these logarithms here, inequalities are going to be the exact same as our equations. So here I have log base 10 of x is less than or equal to 2. So I want to simplify the logarithm first. So the first thing we can do is put 10 as the base of both sides, because 10 to the log of x, or 10 to the log base 10 of x, will simplify to just what? X is less than or equal to, well, 10 squared is 100. Now we do have to be careful with logarithms, because with our exponentials that we just saw, well, what we plug inside the exponential can be positive, negative, it can be any number. However, what's inside the logarithm cannot be negative. We cannot have a negative number inside the logarithm. So when I look at this here, x is less than or equal to 100. Does this include negatives? Can I have a negative value for x that would make this statement true? Right here. Would negative 1 be less than or equal to 100? Well, is negative 1 less than or equal to 100? Yes? No? What do y'all think? Negative 1 is less than 100, yes? So what we have to do is we have to apply a restriction. We have to find out what value x can be. What is the smallest value x can be? So we take what's inside the logarithm, which is just x, and we say that it has to be greater than or equal to 0, because whatever's inside a logarithm cannot be negative. It has to be greater than 0. Well, and then we solve it for the value of x. Well, that is solved for the value of x. X has to be greater than or equal to 0, yes? So we'll add that on, saying that our solution is that 0 is less than or equal to x is less than or equal to 100. So our solutions for x cannot be less than 0 or greater than 100. And that's it. Now, if it works out that our solution does not include negatives, we don't have to do this step. We only have to do it if negative numbers are included in our solution set. Are there any questions on this here? So let's look at this one here. We're going to look at this one twice. I want to look at it once where x is inside the logarithm, and I want to look at it once where x plus 9, that entire statement, is inside the log. So for solving this here, we need to get the logarithm by itself first. And we can do that by doing what? Subtracting 9 from both sides. We need to get the log by itself, and right now we have log of x plus 9. Well, 9 minus 9 will give us 0. So we'll have log of x is less than 36. Then what can we do next? We can put both sides to the base of 10 because 10 to the log base 10 of x would simplify out, giving us just x is less than 10 to the 36. And I'm going to leave it as 10 to the 36 because we don't quite have enough room. I don't have enough room on that board to really write this out. So this is 1 undecillion is 10 to the 36. But as you notice, again, x is less than 10 to the 36, so our negative numbers are still included. So what that means for us here is that we still have to see inside the log would be x greater than or equal to 0, because whatever's inside the log cannot be negative. It cannot be less than 0. Well, that's still just going to be greater than or equal to 0. So that there would be our answer. That's all we would have for this here. Any questions on any of this here so far? Okay, I want to re-look back at this and I want to change the problem just a little bit. So we're going to say log of x plus 9 is less than 3. So you can write this out to the side. But we're going to look at this one here. I made the other side, instead of using 45, I chose 3 so that the numbers will be a little bit nicer. Because at this one here, unlike the one we did with x being the only thing inside of the logarithm, it is already by itself for this one here. So we can go on and put both sides to the 10th power, because 10 to the log of x plus 9 will simplify to just x plus 9 is less than 10 to the third, which would be 1,000. Any questions on any of this here? Now at this point here, we do need to get the value of x by itself. So we can subtract 9 from both sides, which will tell us x is less than 991. Now again, we still have negatives included because we're talking about x being less than 991. So what's inside the logarithm cannot be negative. It cannot be less than 0. So to find that, we do set it up as x plus 9 is greater than or equal to 0, because whatever's inside of there has to be greater than or equal to 0. Now this time it's not just x is greater than or equal to 0. We do need to solve. So we can subtract 9 from both sides, which tells me that x has to be greater than or equal to negative 9. Because if I plug 9 into this, or negative 9 into this, well, negative 9 plus 9 is 0. We can have 0 inside the log. So for this here, any numbers between negative 9 and 991 will be true for this here. Any questions on any of this here so far? Are we good with this here? We just have one more. This is the last one that we're going to look at here. So we have 2 natural log of x minus 1 is greater than 4. So what is the first thing that we can do? We can add 1 to both sides, yes. And we add 1 to both sides, well, these will cancel, giving us 2 ln of x is greater than 5. And then what can we do next? We can divide both sides by 2. And if we divide both sides by 2, we'll get ln of x is greater than 5 halves. Any questions over anything we've done thus far? Now, what do we need to do next to solve for the value of x? We need to put both sides to the base of e. P is e and ln of x will simplify, giving me just x is greater than e to the 5 halves. At this point here, we just need to type e to the 5 halves into the calculator. Because if we type this into the calculator, we'll get 12.1824, and it continues on. Now, any questions on this here before we wrap this one up? So again, if we cannot have negatives inside of the logarithm, yes? Does x greater than 12.182, are negatives a possibility for x? Is -1 greater than 12? No. So can I even have negative numbers for the solution? Well, no, they're not included. So this here is our answer. So the only time we have to figure out what values of x will make what's inside the logarithm 0 is if they are included in the solution set. Otherwise, we don't have to find them.